illustrates how a heat pump operates. Generally speaking, a heat pump transfers heat from the air in the room to the water in the tank with the aid of a substance called a refrigerant. As it cycles through the system, the refrigerant undergoes variations in temperature and pressure, as well as alternating between liquid and vaporous states. Let's examine the 4 stages in one complete cycle. In the beginning of a cycle, the refrigerant is in a cold, low-pressure, liquid gaseous state, flowing through tubes that are exposed to room air. It is colder than the room air, so the heat in the air moves to the refrigerant. This is because heat always wants to move from warmer things to cooler things. To facilitate the heat transfer, the tubes are connected to an evaporator, a heat exchanger much like a car radiator, with many fins designed to increase the absorption of heat from the warm air into the cold refrigerant. A fan amplifies the absorption by increasing the flow of room air over the evaporator. The heat added to the refrigerant causes its temperature to rise and the fluid to become a warm, low-pressure vapor. As the refrigerant changes from a liquid to gas, large amounts of energy transfer take place. Once it's passed through the evaporator, the refrigerant is a warm gas, the cold liquid having been warmed and vaporized by the room air. The refrigerant is still not hot enough to heat water, however, so that's where the compressor comes in. The compressor raises the pressure of the gas, which also raises its temperature. Once it's hot enough, the heat will flow from the refrigerant to the water. The compressor next forces the now high-temperature, high-pressure gas further along the cycle into another heat exchanger called the condenser. The condenser is in contact with the water, and the hot gas now gives up its heat to the colder water. As heat leaves the gas refrigerant, it cools off below its condensation point and changes from a gaseous state to a high-pressure liquid state. The change from gas to liquid facilitates the large transfer of heat energy to the water. Finally, the now cooler, high-pressure liquid refrigerant passes through an expansion valve. As the refrigerant passes through the valve, its pressure and temperature are greatly reduced. Now cold and in a vaporous state, the refrigerant is once again ready to absorb heat from the room air and repeat the cycle.